In this session, we're going to look at how analog signals are converted to digital. When recording audio digitally, the analog sound wave needs to be converted into a digital signal. Digital is basically a series of ones and zeros. To do this, the digitization process has to sample the sound wave in such a way during compression that when the signal is decompressed, it represents the original sound wave with high fidelity. To achieve this, the wave is sampled so many times per second along the x-axis. A second measurement is taken along the y-axis to measure the amplitude of the wave, also known as bit depth. But how many times should the sound wave be sampled each second? Harry Nyquist came up with a theorem that sound should be sampled at twice the rate of the highest frequency. As mentioned before, the human ear has a range of 20 Hz to 20 kHz. Therefore, using Nyquist's theorem, the rate should be 40,000 samples per second. If samples were made at less than twice the highest frequency, distortion could occur with certain frequencies. This is called aliasing. To compensate, a low-pass filter is used before the analog to digital conversion occurs, to help block high frequencies. It was determined that the highest frequency to be recorded was 22,050 Hz, which required a sample rate of 44.1 kHz, which became the standard for CD audio. Modern audio recording systems can sample either at 48 kHz or 96 kHz, with a bit depth of 16-bit or 24-bit. Therefore, the y-axis measured at 16-bit has 65,536 steps for measuring amplitude or volume, whereas 24-bit has 16,777,216 steps. However, by changing the bit rate from 48 kHz to 96 kHz, the file size of the recording is twice as big. If the bit rate is changed from 16-bit to 24-bit, the file size becomes 3 times larger, so consideration needs to be made relating to how much hard drive space is available to store both audio and video clips. If the project is small, this may not be such a problem, but it can be for larger projects. In this session, we've looked at how analog signals are converted to digital. As an exercise, use Audacity to record a series of 1-minute audio clips. Start with 48 kHz at 16-bit and then 48 kHz at 24-bit. Follow this with settings of 96 kHz at 16-bit and again at 24-bit. Ensure you save each file to a folder on your hard drive, then check to find out the different sizes of each file you have created. What do you notice?